Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will discuss Barton McCombie deoxygenation reaction. Yesterday we discussed Barton Decarboxylation reaction. In Barton Decarboxylation reaction, carboxylic acid or acid halide are converted into alkane. So it is the extension of Barton decarboxylation reaction. In Barton-McCombie reaction or Barton-McCombie deoxygenation reaction, alcohol are directly converted into alkane. How? Let's have a look to the reaction condition. This alcohol are first react with carbon disulfide in the presence of sodium hydride and methyl iodide. It generates thiocarbonyl functionality or thiocarbonyl derivatives. This thiocarbonyl derivatives then react with radical initiator as a bis-isobutylonitrile in the presence of tributyl tinhydride, and as a result, thiocarbonyl derivatives are converted into alkane. How this alcohol react with carbon disulfide and in the presence of sodium hydride and methyl iodide to produce thiocarbonyl derivatives. So we will discuss it in the reaction mechanism, and then this how thiocarbonyl derivatives react with radical initiator as a bis-isobutylonitrile in the presence of butyl tinhydride. As we know that this is the radical initiator, first radical will be generated from as a bis-isobutylonitrile, which then interact with tributyl tinhydride, and tin radical will be produced. Then this tin radical react with thiocarbonyl functionality or thiocarbonyl derivatives, and it resulted in the formation of alkane. So let's have a look to the reaction mechanism for this deoxygenation reaction. In the first step, as a bis-isobutylonitrile homolytically glued in the presence of heat to generate tertiary radical. This tertiary radical then interact with tributyl tinhydride, and it resulted the homolytic cleavage of tinhydride. So one of the bonded electron will move on the tin atom, and one hydrogen radical will interact with this tertiary radical, and it will form this compound. So this is tin radical is the radical catalytically active species. This catalytically active species then react with this thiocarbonyl functionality or thiocarbonyl derivatives. As we talk about that how this thiocarbonyl derivatives will be synthesized, so first have a look to the synthesis of this thiocarbonyl derivatives. Let's suppose ROH is the structure of any type of alcohol which react with carbon disulfide. This is the structure of carbon disulfide in the presence of sodium hydride, which act as a base. So what will happen? Base will abstract one of the proton of alcohol. So this is hydride, sodium hydride. This hydride comes from sodium hydride. So this hydride will abstract one of the proton from alcohol, and it will remove in the form of hydrogen gas. So it is removed in the form of hydrogen gas. So what will be produced from this alcohol? It will result in the formation of alkoxide ion. It will produce what? Alkoxide ion. Then this alkoxide ion will attack on the carbon atom of carbon disulfide, and one of the bond between carbon and sulfur will be break towards sulfur atom. So how? Oxygen, carbon, so it is sulfur, and this is sulfur with negative charge. So this bond is break toward sulfur, so it becomes negatively charged species. Now, as we talk about in the reaction, that this sulfide ion will react with methyl iodide, as methyl iodide is already present in the reaction mixture. So now this sulfide will attack on the methyl iodide and the bond will break towards iodine, and it will result in the formation of this thiocarbonyl derivatives. Now this thiocarbonyl derivative will interact with tin radical, as we already discussed in Barton Decarboxylation reaction. Then this tin will interact with the thiocarbonyl functionality, and the pi bond between carbon and sulfur of thiocarbonyl functionality will homolytically cleave, resulting in the formation of carbon radical. This is carbon radical. As a carbon radical, it directly attach with oxygen of alcohol, so the bond between this carbon and oxygen will homolytically cleave, and it will result in the formation of carbon radical. Now what will happen? In the next step, this carbon radical will interact with the tinhydride. Now it interacts with tinhydride, as we discussed in the previous reaction, that this tertiary radical interact with tinhydride and it resulted in the formation of tin radical. So same in the case with this type of radical, it interact with tinhydride and this bond is homolytically cleaved, which resulted in the formation of this catalytically active tin radical species with the resultant formation of alkane. I hope you enjoyed the videos, and if you have any type of question, you may ask in the comment section. Thank you so much. The Allah Paman.